Hey everybody, I'm here with one of the professors at Clemson University's International Center for Automotive Research, and we're going to be diving into cyber-physical security systems. Please tell me a little bit more about what you're doing and what the implications are for this research in the real world.
Thank you. I'm Behnaz Papari from the Automotive Engineering Department. I'm an assistant professor and joined Clemson University at 2022. My main research area, if I want to briefly tell about it, is about the cyber physical security systems with respect to the control system designs for the different variety of the applications. For instance, for the automotive applications, for the smart grid applications, for the ship power system, specifically the Navy ship power system, and we're trying to leverage any type of the artificial intelligence based method that we have for those control design to secure it with respect to the abnormal condition. You may know that every system that we have, it could attack by someone, as an example, attacker, or even could be affected by some uncertain condition or disturbances. For instance, imagine you have a fleet of vehicles and as one of the user, you're trying to leverage your vehicle when you have a severe weather-related conditions, for instance, hurricanes. And in those type of uncertain conditions or environment, you need to be able to define that how you would be able to make your control system design more secure to those uncertain conditions that could be attackers, could be weather-related issue, or any other abnormalities that you have in your system and in your operation system. What we have here, and specifically in my lab, Secure Energy and Automation Laboratory here, trying to leverage some hardware that we have here for the modeling of the electrical vehicles, hybrid electrical vehicles, or any power system that we need to improve the resiliency factor on it. Why do we need to do it? Because, and why is important, I can say that every one of you have a phone, every one of you have a laptop, and or even those digital devices that need, daily uses and daily basis uses. And we trying to find out how first we would be able to model those devices, and then how we would be able to secure the control system for those devices to improve the functionality and operation of those devices. As an example, for instance, we are in an automotive engineering department, so as a main application we have a vehicle, and with all of those technologies, when we design the best control system for the vehicles, how we would be able to secure those design against the attacker, against the uncertain condition that could be anything, abnormalities or any other fault or any other things. So I can say that we need some hardware that first modeling vehicle in a real time is as a good example of a real world example to see that what's going on in a vehicle in a real world. Then we need some other hardware to be able to model the control system, then see that how they would be able to talk to each other, those hardwares, and in a real world application like a vehicle, how would be the vulnerability point of that application. Here, as you can see, that we have some real-time simulator, OpenRT as one of those big modules that we leverage, work with it, and is not limited to that type. We had even a SpeedGoat module here, down here, as another real-time simulator for modeling the power system, modeling the vehicle, modeling or Typhoon as another real-time digital simulator. When we model the vehicle as a main and heart of the application that we're trying to design the control system for it, then we need some controller as some hardware for running the control code, and here you can see that some Raspberry Pis and controller system that we would be able to run our control design through those hardware to see that how we would be able to securely control the vehicle. But modeling of the real-time modeling of the vehicle and also real-time modeling of the control system have some challenges because it's the real time and is make it really challenging from timing point of view. As you may know that attacker usually leverage the deficiency of the knowledge of the designer, control designer, or the one who designed the vehicle, and then trying to leverage those gaps, then attacking the system, and then get the control of the system for here as a vehicle, then make it out of the user hands. So we're trying to find that, first of all, what is the vulnerable points of the system, our vehicle, and then how we would be able to make control design more robust against those gaps, against those vulnerability points. It make it a little challenging because you need to first thinking about attacker as an attacker to see that what's going on in their mind and what was the vulnerable point that they can introduce, basically intrude the system through, and then interfere your systematic operation. And here, my students in some of the projects that we had with the US Army, we had with the National Science Foundation and DOE, and even industry, trying to figure it out in a different project, how they would be able to improve controllability of the vehicle with respect to the cyber physical security, and also physical fault that have in a system. Not necessarily always we have an abnormality when we have an attacker. No, sometimes physical problem in a part of the vehicle causing issue, and control system need to know that, okay, that one, someone attacking my vehicle or not. My vehicle physical part, sensor, or any other part, systems have any abnormality that control system would not able to make it up. So in one of the project, my PhD student worked on it, trying to figure it out. First of all, when we see some abnormality, what exactly is this abnormality? Is it a physical fault or is a cyber attack? Other students in the project trying to figure it out, okay, let's to see that what if we have a cyber attack in a vehicle, how we would be able to detect it first, how we would be able to remove it from the system. So those is the outline of the project that we usually trying to convey in our research group and our research team here. And of course, those equipment that you saw behind of me help us to be successful and and making it whatever we want in a modeling, in a control system, in a cyber physical security, always in a real time. When I'm talking about real time, I emphasize on it. It means that whatever in reality you experience, those equipment would able to model it for you and then operate at the real world sampling time example. And that really is amazing equipment and opportunity that we have here at Clemson University. Why? Because not many of the other universities have those capability. Those modules that you see, those two as a real-time digital simulator or Papari module, it costs almost $200K, and the price of those modules is not that affordable for the most of those university or even other project. You need to have a big project, and fortunately one of our project with the US Army, we dedicated this amount of the money to purchase those equipment, and then our students, undergraduate students, or even graduate level students leverage it for their research. And I can say that the good point that I really love about our research team, that I always engage with the high school students, and I already have 2 high school students who for over a year and over 2 years actually, working with me in the lab with the other research team to build some of this setup here, helping them, and then let them to leverage it for their project. In this way, they engage what was in a university level project, what was going on, and also what was the my interest to engage with the others for the my future step if I want to continue and then join any program. In the automotive engineering department, I can say that we have a variety of the expertise. For instance, I came from the electrical engineering department and working in automotive engineering department with this application. I have a colleague from the mechanical department, and here in the automotive engineering department, we have an awesome opportunity for our students to start it from the scratch here, develop their skill set for the research, and then if they interested, keep continuing for making the their progress in educational for the graduate level, and basically complete the chain from the bachelor to the PhD with the emphasis on the automotive applications, which is not really possible or available on other universities. Some of them not even provide those program, but here with the depths of the industry that we have around this Greenville area, it makes it really good opportunity for our students that basically they do not look for the job a lot after the graduation. They can easily find their industry that they would love to join, and with the skill set that they here with the other research group or here they equipped with, easily start their job down there. And so far I had at least 3 students that they find a job locally with a good industry that they look for as an automotive application, and I'm pretty would not be any problematic for anyone.
Kind of following up what you said, I remember actually a video that went viral a few years ago that was an automotive like media correspondent that was test driving a vehicle, and they were actually demonstrating that the vehicle could be taken over by somebody from the outside while they're doing this video. I don't remember that video that went viral. That's the kind of cyber physical systems you're talking about here.
Exactly.
Is like a vehicle that could be taken over by somebody externally that would create an unsafe environment for the driver. And then you mentioned the military, and I can imagine that the same scenario would apply in the theater of combat or theater of war with military vehicles, where, for example, like in Russia and Ukraine, if Ukraine is sending drones into Russia or Russia into Ukraine, if the other side was able to control those drones, they could disrupt their attack and do all kinds of like advanced maneuvers to disrupt that kind of like military application. So I could see strong applications for military, which is why a lot of funding and research probably happens for the military. It's a really important piece.
One on one project actually with the Navy about the transportation sector is that how they make a more secure ship power system design, in a case that when we have several of them and they trying to communicate with each other, specifically in the battle mode. And I can say that one of my students actually, Ali, one of PhD student, leveraging those equipment to modeling the control system design for the Navy ship power system. I can say that when you're talking about automotive and application, range gonna be kilo max gonna be or truck even or whatever. But when we're talking about the ship power system, is the megawatt range. So your control system basically should be enough robust and enough secure to save all of the users that they having it. In a transportation sector, regardless is the vehicle or vehicle fleet or even ship power system, they dedicated a lot of money to that area to make it, specifically with the military application, make it more secure and robust in an abnormal condition, regardless what is this abnormality type.
Okay, and I think you have some things pulled up here on the big screen,
Right.
so why don't we go ahead and take a look at that?
Trying to design the control, improve the control for the experimental setup that we have for the electric vehicle power converter. And as you may know that vehicle basically need to convert the power from the, is a DC type power. So the power converter as a power electronic devices that we have in a vehicle need to be securely communicate with the other modules or subsystem in a vehicle to make it the really healthy communication, and at the end of the day control system would be able to provide that optimum operational set point for the vehicle, and then for the fuel consumption, for the battery usage, making it the balance between these two sub-modules. But if in a power electronic level of the electrical vehicle, some fault, physical fault, or even attack happen, that module or subsystem won't be able to safely and securely communicate with the other subsystem in a vehicle. So my student in this project trying to figure it out, detect what's going on in the vehicle application and subsystems, and which one of those subsystems is under abnormal condition, attack or physical fault. And when detect those, that okay, we figure it out in a power electronics system of the vehicle, electrical vehicle, we have a fault, physical fault, or we have an attack in a battery energy management system. So when figure it out how we would be able to improve control system to push the attacker back, physical fault back, and then let to vehicle keep continue and operate in a healthy condition that it was before attack or abnormal condition. And as you can see, that is the basically application of that is the Army vehicles that we have from our project, power converter that we have. We're trying to model it first with those hardware that I showed you, and then design the control system, and then modeling the attack and physical fault in the vehicle or combat vehicle for the Army, and see that how we would be able to detect those abnormal conditions, how we would be able to remove them from the system and bring the vehicle, combat vehicle, back to the normal operation mode. And as you can see that they basically leverage all of those real-time equipment, and we calling it control hardware in the loop. When we leverage the real-time simulator controller, and what's the meaning behind of the real-time control hardware in the loop, or they calling it chill. Not chill in meaning the other meaning that you used to, but I can say that basically we're trying to design the system as a real world example. Vehicle that we have, battery system of the vehicle, electrical vehicle, or power electronic system that we have in a vehicle, modeling it in a real time is look like what exactly in a real world application of vehicle working, then design the control system for that physical system to make sure that everything, and then running it in a real time to make sure that everything running in the same sampling time that when vehicle start. Then our student figured it out, okay, how we would be able to right now detect the attacks, detect the physical fault, and then remove it from the system. When we have a attacker who attacking the combat vehicle, Army combat vehicle, how we would be able to detect it, how soldier as a main user of those combat vehicle would be able to figure it out what's going on around me. I know that the combat vehicle not working in a way that should be, but I don't know what's going on. So in this project we're trying to detect the model first, model several types of attack, and then detect which one of those attacks we face with it, and soldier who using that vehicle basically figure it out, okay, right now our vehicle, our combat vehicle is under this type of attack, how we can modify the control system to be able to put ourselves in a safe zone until we figure it out how we would be able to, make fixing that issue. So in this project, our students successfully detect different types of attack and also would be able to improve the control system and make the control system design more robust toward the other type of attacks, and during in a transient mode that vehicle under attack to making it what would be the best decision from the control point of view to save our soldier from the real dangerous area to the safe zone, and then later on they, in a depth go through it to see that the vulnerability point of the system.
Okay, so if I understood what you're saying here, let's say there's a soldier in a combat zone and all of a sudden their tank or their vehicle stops functioning and they're trying to get out of an unsafe zone or trying to get out of a danger zone to back to their base, and their vehicle stops working all of a sudden.
Right.
So you're developing systems that would allow them to temporarily develop a workaround in real time so that they can bypass what's taking place and what's controlling what the attacker is doing to, like, let's say, disable the vehicle.
Yes.
Bypass it in real time, gain control of the vehicle so they can get back to a safe location.
Exactly. And that is really, really important. I can say that really important for the Army project, and I can say even for the fleet of vehicles. When imagine you have 1,000 of electrical vehicle around and every one of them trying to leverage the charging station. If someone as an intruder enter to the system and then play with the charging capacity of the those vehicles or charging station availability, imagine you have 1,000 people who does not know that 1,000 users doesn't know what's going on, which charging station they need to go, and even from the city level they can make a lot of mess for the city, for the utility, and utility trying figure it out, okay, in which one of the stations, charging station, we have those attacks. In which one of them we need to, making him out of the system temporarily until the rest would be able to operate, and then we figure it out, with how we can securely bring that charging station back to the operation mode. And I said that when a scale of the system goes up, importance of the security, especially cyber physical security, really goes up. And why? Because the large scale demonstration, specifically in real time, really hard to manage. And when you're trying to control that 1,000 control nodes in a real time, checking them in a real time how secure they are is really is the matter. And here, fortunately, we would be able to, successfully implemented the multi-site hardware in the loop instantiation in our lab by connecting the hardware of our lab with the other labs in the main campus in Clemson, to be able to increase the number of control nodes, for instance, from 100 to 400, 500 control nodes, all in a real time. It was a little challenging for us, but it was a really good opportunity to provide the largest scale instantiation by connecting two different labs, which geographically they are not close to each other.
Yep.
And also we went further and we basically trying to increase the scale of the system that we have here a lot more than we did more for the geographical distance. We connected our lab here at the Greenville to the main campus in the Clemson, and also in a Clemson campus in a Charleston. So right now, if we're trying to make one real-time hardware in the loop instantiation, we would be able to go around almost 1,000 control nodes within Clemson campus, Greenville campus, and also Charleston campus as a multi-site real-time hardware in the loop capability.
Wow, okay, that's really exciting. So as we've seen kind of a trend towards digitization, electric vehicles, more electronic systems controlling vehicles, controlling kind of the infrastructure for the military applications when they're at war in another country. This clearly, and then also a trend towards more cybersecurity risk and vulnerabilities, all these different vectors of attack. This becomes a more and more important area to research, to understand, and more of our military apparatus, more and more of our vehicle systems are being controlled by these digital systems.
Right.
And so this is becoming a bigger problem in society, in global geopolitics, and the theater of war. So it's a really exciting field. If students would like to get more information about your research and about applying to come to Clemson or to come to ICAR, or even any of the other departments, because I imagine if they worked in other departments, they would also be able to work with you. Do you have a website? Do you have any kind of way to get a hold of you? What's the best way to get a hold of you?
Yeah,
for
I can say
students?
that. Feel free to contact us by email or even, my website, because my website, which one of our valuable high school students who join our team design it for us, is really have informative information about the current project and named as a Secure Energy and Automation Laboratory, or SEAL. And you can reach out to that, or we have different references or equipment or even resources that we leverage, or industry who work with it. You can definitely find more information down there if you need it.
Okay, and another thing you mentioned earlier in the interview was that there's a really good path to getting jobs working in industry when we come here to do research in a university setting like this.
Right.
Here at Greenville, this is like an actual manufacturing hub for the United States.
Exactly.
So there's a lot of manufacturers here, and a lot of the research I do in my lab, and it looks like you're doing in your lab, is in partnership with industry partners.
Right.
And there's a really strong, viable path towards getting internships and getting work and getting jobs with companies after coming to Clemson.
Exactly. I can say that two undergraduate students, high school students that I have, they easily find internship in the BMW, is basically the other side of the road here. And also with the master students that have, they easily, they had the opportunity to, as an internship, joining those industry, because they already know Clemson University very well. They know that automotive engineering department with a big backbone, and and they know that we have lots of the very well high level skill set students. So finding the job for the one who interested in automotive engineering industry, not at all be a challenging problem here. It was easy, and even from a student point of view, the reason my student told me that I really, as a high school student, so that I really want to work in the industry, which is across the road from my house. I want to choose the automotive engineering department as a bachelor. I know that freely can find a job, and I need only a skill set. So I'm looking for those skill sets in my bachelor program, and so that sounds a good plan for you. And I'm not, the one that I'm not the one to tell you that no, is not. So that is very, very well guarantee that for the job opportunity for the many of the students who love vehicle and automotive industries.
Well, great. Thank you so much for walking us through your research, and I'll put the website up on the video for anybody who wants to look out and get more information, reach out to you. And thanks so much for walking us through everything. I really appreciate your time.
Thank you for the opportunity. Very welcome. And any question, anything, feel free to reach out to the website and email.
Okay. Thank you so much.
Thank you. Bye.